Welcome to my student. Now today's lecture we are going to learn the topic natural products. In this topic now we have studied the topic alkaloids. Alkaloids are a large number of groups of the plants. They contain organic compounds. At least one nitrogen atom is present in the forms a part of heterocyclic ring, which is called as alkaloids. It mainly the at least one nitrogen and part of heterocyclic ring must be present. This is called alkaloids. Now we have seen sources of the alkaloids. About 5,000 alkaloids found in plants. They can be widely distributed in mainly dicotyledons and less abundant in monocotyledons. Many alkaloids can be optically active in nature. For examples, glycosyl's alkaloids, which is found mainly alkaloids of selenium and vetranum groups as glycosides of the sugar like glucose, rhamnose, etc. Ester alkaloids mainly found in atropine, cocaine, etc. Amines alkaloids mainly found in piperine, and the salt of organic acids observed in the nicotine. So these are the main examples of these alkaloids. Now we have going to classifications. Classification of alkaloids mainly basis of which types of heterocyclic ring is present. So first type is a type of heterocyclic ring, examples and the name of the plants which is obtained by such alkaloids. Firstly, is a pyrrolidine ring is present. Our name is a pyrrolidine alkaloids. For examples, this is a higrin. For examples, the coca alkaloids or coca plants which is obtained by such alkaloids. Other is the piperidine or pyridine ring is present. So name is a piperidine alkaloids. So name is a quinine. For examples, which is obtained from hemlock alkaloids. Another is a pyrrolidine and pyridine ring is present. So name is a pyrrolidine pyridine alkaloids. For examples, nicotine, which is obtained from tobacco plants. So name is a tobacco alkaloids. Next is a tropane alkaloids. So such types of ring can be there. So name is a tropane alkaloids. For example, atropine, which is obtained from belladonna plants. So name is a belladonna alkaloids. This is a quinine type of heterocyclic ring present. So name is a quinoline alkaloids. So such alkaloids, for examples, the quinine, which is obtained from cinchona plant. So name is the cinchona alkaloids. Next alkaloid is the indole alkaloids. Due to indole ring will be there. So it is a indole alkaloids as like this. Name me for example gramine, mainly obtained from barley plants. So name is the barley alkaloids. Now, these are very important reactions for the final exams or another the competitive exams like SET also there. So these reactions are very important. In the first step, what happens is pyridine can subject to Raney nickel. So you know that role of the Rani nickel. Rani nickel are used to reduce carbon-carbon double bond to single bond. So this carbon-carbon double bond can be reduced to single bonds to get pyridine. This pyridine then treat with methyl iodide. Then what happens? Lone pair of those nitrogens which is present. So those lone pair is attached on this CH3 replaced by I. So this CH3 attached to these nitrogens, replacing the hydrogens. Another molecules of methyl iodide can treat. So lone pair of those nitrogen can attack on this methyl, replace iodide. So giving the lone pair, so it is present, electron deficient, so positive charge is here. So 2 methyl group is attached to nitrogen. And then after formation of such intermediate, it taken as a moist Ag2O, silver oxide. Then what happens? So breaking of this bond may take place. Breaking of those bonds. It means formation of the salt. So minus loss of the water molecule by heating conditions. So breaking. This is hydrogens. So break like this. This hydrogens. OH minus is strong alkali. So this strong alkali can take the protons from these carbons and form carbon-carbon double bond is here, and breaking of such bonds. That is carbon-nitrogen bond can break, right? And then form the carbon-carbon double bond. Similarly, hence the lone pair of the nitrogen can available, attack on methyl, replace the iodide to get the 3 methyl group are there, and therefore the lone pair is given to methyl, therefore it is electron deficient, having the positive charge on nitrogens. Similarly, by heating those molecules, so those protons, these carbons, this carbon having 1 proton, so those protons can lose as a water molecules, that is the OH are here, OH, and these H water molecules can be lost to form carbon-carbon double bond is here, and breaking of those bonds can be there. And there's such formations of carbon-carbon double bond on this side and this side. After isomerization, it means those protons, it is one of the protons. Sorry, these protons are form carbon-carbon double bond is here, and those double bond can transfer to this carbon. So CH2 convert to CH3. Sorry, this side, no? Any one side can transfer these carbon-carbon double bonds. So here this right hand side transfer the carbon-carbon double bonds. So isomerization, it means only change the position of the carbon-carbon double bonds. So this carbon-carbon double bond will be changed. So this is the protons from the carbon-carbon double bond is here, and this carbon-carbon double bond can transfer to here to form the CH3 is here, CH3. Okay, so position only change the carbon-carbon double bond. Similarly, other examples also there for Hofmann exhaustive methylation reactions. For those reactions are very similar to the Hofmann exhaustive methylation reaction. See here. So those molecules see very large, but it is very simple reactions. By using H2SO4, concentrated H2SO4, what is the role of concentrated H2SO4? It is a dehydrating agent. So this is loss of water molecules from these hydrogens, right? So those hydrogens and loss from this carbon-carbon double bond is here, and loss of OH. So minus water molecules. Next type, what happens? The lone pair of those nitrogen can attack on methyl and replace iodide to get the methylation at this nitrogen. So lone pair will be given to methyl, therefore it is electron deficient to form the positive charge here. So this is a small positive charge, can see is here, and therefore after vacuum distillation, then what happens? The breaking of the bond can take place. How will you break? So this break the bond. Proton are here. One of the proton is here. So those proton can take this OH minus water molecules. So this OH minus and these protons form this carbon-carbon double bond is here and breaking of those bonds. This nitrogen and carbon bond breaking, so thus such molecules can be as. Similarly, we can take the methyl iodide. What happens? The lone pair of the nitrogen can attack the methyl iodide, replace the iodine, and similarly, third methyl group is there and positive charge due to electron deficient. Similarly, this silver hydroxide OH minus take the proton. Which proton? These protons can take, so form the carbon-carbon double bond is here. In between this carbon-carbon double bond form is here, and breaking of this bond, nitrogen and this bond can break. Formation of such a name is a tropylidine alkaloids. Now, next point, we are going to discuss the structure determination of nicotine. Last lecture we have seen the structures of citral. Similarly, now we have seen the structure determination of nicotine. The leaves of tobacco, they will contain alkaloids like a nicotine, which is present in the plants as the salt of malic and citric acids. The leaves and stem, of tobacco plant, they are dried and make the powdery form and be extracted with water to get the tobacco. Similarly, the molecular formula of nicotine, they contain C10H14O. Now we have seen nature of the nitrogen atoms. It means it is a primary, secondary or tertiary nitrogens can be determined. Nicotine reacts with two molecules of methyl iodide and to form dimethylodine. And therefore, both nitrogen are tertiary. Right? So the nicotine can treat with two molecules of methyl iodide and to get dimethylodine. And therefore, it shows that this nitrogen present on nicotine is the tertiary. Third reactions. So nicotine on oxidation with potassium dichromate, it gives a nicotinic acid, right? Potassium dichromate. What is the role of potassium dichromate? Potassium dichromate are used for the oxidation reaction, and therefore nicotine can treat with such reagents to use oxidation reaction to form the nicotinic acid. Hence, the partial structure of nicotine is as like this: the pyridine ring and C5H10 side chain. Therefore, pyridine nucleus and side chain is contained COH group. Now, how types of side chain will be there in the nicotine, which is confirmed by using various chemical reactions. Now C is here. The both nitrogen atoms shown by tertiary, therefore indicate no pi pyridine nucleus, right? Firstly, nicotine zinc chloride distillation with soda lime, it is a calcium oxide. They use a pyridine ring, pyrrole and methylamine. So these three molecules will be given on distillation with nicotine zinc chloride. Secondly, the nicotine on heating with concentrated hydroiodic acid at 150 degrees centigrade, they use methyl iodide, and hence side chain must contain N-methyl group. Above reactions that will confirm the pyridine ring N-methyl group indicate 5-membered heterocyclic ring containing the nitrogens. Right. Next reaction can be done. Nicotine on mild oxidation with silver oxide, like this silver oxide, they use the nicotyrene. They use nicotine by losing the 4 hydrogen atoms, and hence nicotine must contain pyrrolidine ring. Nicotine must contain pyrrolidine ring. This 1, 2, 3 and 4 hydrogens will be lost. So it contains pyrrolidine ring. And side chain must contain the methylpyrrolidine. Side chain must contain methylpyrrolidine, which attach at the position 2 and 3. This is a third position and this is third positions of the pyridine and second position of the pyrrolidine, right? Third position of the is a pyridine, so third position of the pyridine and second position of the pyrrolidine with attached at, and hence structure of nicotine, it may be the structure first or structure second. So which is correct? Attached to third and second position or attached third and third position? So which is correct? Thank you. So this structure, it may be confirmed by using the various chemical reaction to synthesize nicotine.